Okay, let's get started. It is 6 o'clock exactly. First order of business, the time we're starting the class. By popular demand, we are starting at 5 instead of 6. The reason being that there's an hour wait between this class and the last class, so some students get bored. And the other reason being there's another class that is in direct conflict with this class. So some students might show up for this class at 5, wait for an hour, and then at 6 go to another class, a jQuery class, I believe, that starts at 6. So they'll be able to actually register and attend both classes. Unfortunately, for those people who work and can't get here till 6, you are more than welcome to show up a little bit later. And if you do that, you can watch the first part of the video because I record everything. So you can actually see what you missed, so you don't have to worry about it. And if you really do have a huge problem with it, I can make some sort of an arrangement to waive the attendance or something for you so you don't have to worry about it. And then you'll end up having to watch the videos if you're not going to attend on a weekly basis. Or perhaps maybe you can make arrangements to get here at 5. But unfortunately, the majority of the people like 5 o'clock, including myself. It's going to win. All right, so last time was a couple weeks ago. And so I'll have the TA send a message out, actually. We'll send a message out like the middle part of next week to remind everybody that we're going to start at 5 o'clock next Monday. So it starts this coming up Monday. Next class meeting will be starting at 5. And actually this will be a good test of the email list. So if you don't get an email from the TA, it means you're not on the list somehow. And I believe there's an attendance list going around as well. Are we doing attendance? Okay, good. So make sure you sign that as well. If you're new, you're probably not aware of that. Okay, so last time I said I was going to go through my garage and I was going to find these boot disks that I gave my TA who made it. Well, this was a couple of years ago, and I couldn't find them, so I sent an email message to my old TA from about 2.5 years ago. He's like, yeah, I remember those. I threw them away. So he had them, and he held on to them for a while, and then he eventually threw them away. So I don't have them, is what I'm saying. But you can make your own, and what I'm going to do is give you a couple of URLs that you can write down to make your own. And what is it that you're making? You're making what's called a live CD or a bootable CD or a DVD. You can do both because you need access to a Linux system, Linux or Unix system, in order to do the exercises and the assignments for this course. But you don't want to install it on your computer. I mean, I seriously would not install it on your computer. If you have a Mac, I'm going to demo Terminal, which is all you need. You have a Mac, you don't have to write anything down. You already have a Linux. You have BSD Linux right here on your computer. If you don't have a Mac, you'll have to get access to a bootable CD. So you put the CD in, you turn the computer off, you put the CD in, you turn it back on, it boots from the CD. You might have to set your BIOS to boot from the CD. You can also put it on a USB drive. Both of these two programs I'm going to show you, these distributions, will work. They're small footprint distributions, or distros as they call them, and they work from thumb drives or CD-ROM drives as long as your computer can boot from one of those two sources. So you don't have to destroy your hard drive, and I would not do it actually. Either that or try out the Mac. So I'm not a fan of this one, so I want to give you this other one first. The one that I'm actually kind of a fan of is, and I can never pronounce this, it's called Canopfix. I don't know. This is a very small footprint distribution, and the website, and here actually I'll just push this up here on the top of the screen. These are the two URLs that you probably want to make note of, write down actually, or if you forget you can go to the video and pause the video and write them down from the video. So the first one up here is the knopper.net, Knopnix. And what we're looking at here is essentially a bootable live CD or DVD consisting of a collection of GNU and Linux. So you'll actually boot. Next week we're going to start talking. I'm going to talk about kernels next week. But the disk itself is an image. It's called an ISO if you're not familiar with burning disks. And you download the ISO, you burn the ISO to a CD, and the CD, when it boots up, configures for your monitor and hopefully recognizes your hardware and stuff, and then it boots to an operating system, a Linux operating system. And this one here is actually a variation of GNU Linux, which is fairly standard. In fact, all of these Linux distributions will actually give you a GUI, so you won't have to worry about the command prompt, which is excellent as well. And it's probably just a stripped down GNOME interface desktop, as I talked about a couple weeks ago in the first class meeting. It'll boot up to a GUI desktop, and then you can insert a USB thumb drive, and you can save your files and everything to the thumb drive. And the reason why this is kind of a good option for you is because you can play around. You know, you can delete stuff, and it's all on a CD. You just turn the system off, turn it back on when you've broken it, and it restores itself back to normal. And then you can save things. Both distributions have a plug-and-play kind of effect to them, so you don't have to worry. You just plug in the USB drive, and it'll show up as a hard drive, and you can actually use it to save files too. I wouldn't try to save files to your hard drive, although you might see it as an option in like the file manager or something. Save it to a USB drive. You know, everyone's got those things these days. And then you can open up text files, save text files, and I'm going to go through some of those basic commands today as we start looking at Unix, Linux. But yeah, this top one here, I've used it myself, and it's pretty good. My TAs in the past, couple years ago, they like the DSL. It's called Darn Small Linux, or Damn Small Linux, if you want to call it that. And that's this other link. So if you go to this link on the top, you'll go to this web page, and you'll see the download section. It doesn't matter what version you download, what you use, but make sure you get the live version. You can read through all about what it is you're downloading. There's instructions all over the internet as to how to burn the disk and how to create it. So it might not be a bad exercise for you anyway. So make yourself a disk, make yourself a Unix disk, or a DVD if you'd like to do it that way. The other one here is DSL. What is DSL? Darn Small Linux. And this is nice because it's actually twofold. This is the one that proclaims that it can actually run from a USB drive. Unix I've never tried to run from a USB drive. I always try to run it from a CD. It's a little bigger. It takes a little bit longer to load. My TAs liked this one in the past because you can actually load it and install it on a USB drive. And you can have a fully running operating system on a USB, one of those little thumb drives. And then it's kind of cool because you can boot your computer to the thumb drive. You can have a Linux system, and you can save files. And when you come back, you don't have to start over again. It's all there. So you install. There's two versions of this. Two different ways of doing this. You can download the install disk, run the install, which will also require you to burn it. So one case you're downloading an ISO and you're making a live disk. The other one, and I believe DSL actually has both on the same disk. So you can install and run the live disk from the same distro that you're downloading. But you're downloading an ISO again, you're burning it to a disk, putting the disk in, you're throwing in a thumb drive, and you're selecting the option to install on the thumb drive, essentially. Depending upon your hardware, depending upon your burner, depending upon everything, your install is going to be a little different. I will tell you that the Unix is more compatible. The other one is more compatible with current hardware. This one is not as compatible, but it's smaller and it runs faster. And I don't know, people like it better because it's a little cooler. I don't know. Also installs to a hard drive, and it loads actually a full Debian. So this one is a Debian distribution. The other one is a GNU distribution. They're just, and I'll talk about this later in the course, they're just different kernel builds, different manufacturers. Debian is more grassroots, small embedded kind of environment. The GNU is more universal, it's more of a Red Hat kind of. So you get little differences in terms of the flavor. But here it says, boot the business card CD is what you're making as a live CD. So look for things about live CD, pen drive distros when you download it. There'll be a download. In fact, here's the download link right here at the top of the page. So if you need those two URLs again, I'll put this up for a second or two. And if you don't catch it right now, download the video or go to YouTube. Stop it right here, and cut and paste it if you want. You can't cut and paste off a video, so you can copy it down. So, any questions on creating a live CD for yourself? Nope. All right. Very good. Now, if you're a Windows person, that's what you have to do. If you're a Mac person, you find the terminal, and you open up the terminal, and you're done. And here's my terminal window, and I recently figured out how to make it bigger, so I'm going to make it bigger. So as we go through the lecture, I'm going to show you how the stuff actually looks, and I'll demo a couple of the different things that might be new, because I'm going to going to start in with a few commands, and start in with a little bit more about Linux and Unix and differences between that and Windows and stuff. So today's lecture is a continuation of last week's lecture, which was lecture number 1. And I'm going to kind of get us back up. We just actually went through maybe about 10 slides at the most in terms of the content. And this was an introduction to Unix, a little bit of Unix fundamentals. And if you're already familiar with Unix, this is going to be extremely boring. If you're not, then here we go. This is as low level as I could start with, essentially. Okay, so we went through the history. We went through, the C, and that we all know that Linux was written in C, and it was really an elaborated IDE, integrated development environment for C programming. So some of the shells supported C commands, and we have other types of shells. We actually have a lot of different types of shells, and I'll demo the shell concept in a few minutes. And that Unix was very expensive, and that Linux came out as a kind of a mainstream, kind of a low-level hardware operating system. Runs on a PC. Unix ran on mainframes. You remember that part from the lecture. Linux itself, I don't know what distribution. In fact, 3.0 is just out. 3.0 kernel. Most of the distributions are labeled by their kernel build, and the kernel itself, which is really the topic for next week, is the heart of the operating system. It's like a kernel. It's like a kernel of an apple, I guess. I don't know. It's in the middle. Everything else revolves around it, and it controls everything. And the different builds determine the different version of Linux that you're working with. And about a week ago, 3.0 was live, which is a major upgrade from 2.6. However, it looks the same. They just rebuilt it, essentially. 2.4, you'll find 2.4, 2.6 a lot out in the industry. 3.0 you're not going to find very much of because it's brand new. But the ones that you're downloading are going to be 2.4 or 2.6 kernel builds, which are not going to be the current latest. I would not work with 3.0 at this point anyway, so I want to see it work first. I see the bugs worked out. It's kind of like any new operating system. Why it still exists, I covered this last week as well. 30 years of development, academic, scientific, system tools. The utilities that are involved in it are excellent. The ability to download, to upgrade, to add new features, to add new utilities. It's very much an open source environment, and not like a Windows operating system where you're kind of stuck with Microsoft, and you're stuck with the tools and things that are available. You can install applications, but in a Unix environment, Linux environment, you're installing operating system utilities, and it's a much closer relationship with the user and the operating system than there is on the Windows system. It's not closed off. You have the ability to upgrade it, modify it. It's also open source, which means it's free. You don't have to pay for any of those distributions. The other choice you might have, actually, if you're gung-ho on this, you could probably find a book, maybe with a live CD in it as well. If you don't want to burn your own book, you could probably go to a bookstore and find a used book or even a brand new book with a disc already made for you in it if you want. I don't know if I would go through the process of installing it, though. I don't know. All right, it's also, the system is pretty stable. It's lightweight, makes for easy development. So this is, I believe, where I kind of stopped last time. Yeah, okay, good. So this is where the new information kind of starts in terms of what we're looking at. And so basics is what I want to cover today. It would be extremely boring for you to sit through about 300 commands or for me to read you the man pages of all this stuff. Instead, I want to talk about the features of Linux and demo a few selected commands for you to kind of see the capability and the power in terms of the administrative aspects, some of the Unix admin kind of components to it. So in terms of the interface, we have both the command line and we have the GUI. Bare bones Linux is all command line. The GUIs are added from the command line. It's kind of like how version 3.0 of Windows starts from DOS. You typed it, in the old days you typed in Win, W-I-N, and Windows started. Now it's the opposite way around. You put the system in Windows, and then we have DOS underneath it. So actually, the MacBooks start with a version of BSD Linux, and then it loads a desktop on top of it. So it's more Unix, more true to Unix, and there's a full kernel underneath, which is why we can bring up that terminal window. We can use it. So a lot of developers who are accustomed in Linux and Unix love MacBooks, because you can do all you can utilize practically all of the Linux open source stuff on it. You can run Perl on it, PHP, shells on it, tons of different types of shells, programming tools, and it's all free. So a lot of different kind of philosophies that go on in terms of the development. And you can also set Apache server up on this and turn it into a web server if you want, which is good. And you can use the apt-gets if you're familiar with that in terms of the packages from the open source distributions that are out there. And you use anything that you can use on Linux, you can practically use on here. All right, so in terms of the command line interaction, what we're looking at is a window, and I'll show you the window for those of you. This is as bare bone as you can get. And on this system, it's called terminal, and we get a window. It looks like a DOS prompt. So think of it sort of like a DOS prompt. And in here, the Unix Linux administrator would be essentially typing in commands to perform different things. As an example, ls would give you a list of items, very similar to dir. In fact, I think, believe it or not, nope, it doesn't work. It does not work. dir. And you can see kind of a few things here in terms of the interface. We have our name of our computer. This is Barbara Hicker's MacBook Air. So that's my prompt. And you can see kind of like what shell you're in. As an example, we're in a bash shell. So if I typed in CSH as an example, I'd get a new shell on top of the shell. So the shell itself is the terminal. This terminal window is acting as a shell. When I select the option to open up the terminal, it's giving me a bash shell, and it's automatically logging me in. Now I'm in a C shell, and if I type in BASH, I'm back to a bash shell. The bash shell prompt is actually a little bit more friendly because it's giving me, it's 3.2 version of bash is what's on here. And what is this shell? It is actually the environment that I'm working in. So in DOS, this is because a lot of people think, oh, it's the same thing as DOS. No. In DOS, you type in command, or you CMD, you go to the command window. It's only DOS. Only DOS, and you only get basically commands that are appropriate for DOS, like dir, rename, all the DOS commands and things, In Linux, we have our choices of right now there's about 6 different shells. Only about 4 of them are supported on here. And the shells give us different command sets and different utilities. So the C shell that I was in allows me to write C code, and I can compile it right there in the shell. And I can write scripts that utilize C commands, like printf and scanf and stuff. And I can use those commands inside of shell scripts. And a shell script, for those of you who are not familiar at all, is like a batch file. So in DOS, we can write a .bat file. Nobody ever does that anymore, but in the old days, when people had DOS skills, it's an automatic program that runs. We can have a bat file it stood for batch, actually, and it was batch jobs. We could run, things automatically, and we run through a whole list. Well, that's kind of like what a script is doing in Linux. But scripts in Linux are different from scripts in DOS because they can actually be used as a way of not only timing out work, but performing work in the background and scheduling out different jobs and things that need to be done. For example, most of the backups that are done by system administrators are done through shell scripts. And shell scripts in the Linux environment allow you to write full-fledged applications. Applications that take input, give you output, that actually perform a lot more functionality than a batch file did in the past. And if you think of the concept, if you can write a shell script in C, you're writing a full program. You're just not compiling it. You can compile it and run it as an executable file as well. And I'll talk about that kind of later on. Or you can mix C with like Perl modules, which is very popular, or Python, which is very popular, PHP. So eventually what ends up happening is if you want to do internet development, you learn about Unix and get some Unix skills because the internet is Unix. Everything on it is Unix, 100%. All of the scripting languages are Unix scripting languages. So you fight with it on a PC, you fight with it on Windows. Nobody can really do Perl development or Python, PHP effectively on a Windows system. But you get a MacBook and you get the module, and that you can get GUI interfaces to it as well. It's native, runs just like it would on the server. And you can develop scripts, you can test the scripts out. So Unix itself for development, especially for internet development, is like a match made in heaven because that's what you're developing for. We're actually working on the same platform. So usually students figure that out when they start doing any type of development work that's Unix-based. Then they go, oh, my Windows machine's not going to work for me anymore. Not for that. If you're doing Windows development, then you got to have a Windows machine. If you're doing .NET, you got to have a Windows machine. But if you're doing Java or any of the Unix utilities, Unix scripts, you're writing it on a Unix platform eventually. All right, so I just kind of like opened up this window, and I think I opened up like 3 shells. And obviously I can exit out. So I'm in a bash shell right now. You can see by my prompt. I went into a bash shell, loaded up a C shell, and then loaded up a bash shell from that. And the reason why I'm mentioning this is because we're working in a shell environment. So when we have Unix servers at a company, as an example, we have boxes, they call them. And the boxes, they usually sit on the administrative assistant's desk, normally. They sit in the weirdest places. They don't actually sit, they're huge boxes, huge cabinets. They're not going to sit like, next to the developers. They don't need it. Because what everyone's doing is shelling in. So you have simultaneous users who have logged in to the Unix network. And they're running jobs, scripts, they're writing stuff, accessing files and utilities on all of the boxes. So it's truly what could be considered a distributed operating system. Windows box is a Windows box. What I write on this computer stays on this computer. It's on a hard drive. In a Linux environment, or Unix, well, let's talk about Unix. In a Unix environment, what we've got are several different computers all connected together, distributing services. And one of them might have a database on it. Another one might have a file server. It might be used as a file server. The other one might be a web server. And we share the interface between all the different boxes through shells. So here, as an example, I've got 3 people, because I have 3 shells essentially. I could open up another shell window and have, another shell. So there's no limit on the number of shells. And think of a shell sort of like a session. So in DOS, you only have 1 session. It's single user access mode. You open up a DOS window, it doesn't really matter how many DOS windows, you're the same user, you're logged in, single user at a time. On a Windows system, that's okay, because you're using it, 1 user. On a Unix system that's networked in a distributed environment, you have thousands of users who log in. Just think about how many users are on your ISP. When you have connected to your internet server provider, your SBC GlobalNet, your AT&T, your ITU. I don't know how many students are here today, but I would say probably between 500 and 1,000 people on average probably are logged into it, and they're all using the server simultaneously, and they all have their own session. So think of it more like this login in terms of the prompts here as sessions. So I can exit out of a session, it's going to take me to the last session. So I exited out of the bash shell, now I'm back into the C shell. If I exit out of the C shell, it takes me back to my original bash shell. And to log in, normally if you're on a system, you'd actually have to log in. So I believe the login command is going to work on here. Yeah, it is. So I'm going to log in. I don't know if I have a password on here. Nope, I don't. You know what? It just caused problems for myself. I'm going to exit out and open up another command window. I don't know what actually, you know what? Maybe I know it. Let me see. Wait a minute. Let me see. Maybe I can figure this out. Okay, I got it. All right. You also see we have different settings that might happen. We have things like login scripts. And in a Unix environment, when a user logs in, we can actually set environment variables. We can set the path. We have a bash script that is sitting normally in a user directory, and I'm going to go through the directory structure in a few minutes. We have utilities that we can assign. We have shells that we can assign. In fact, what if the user is a novice and doesn't want to use a command prompt? We can set a desktop for them. We can select Genome or KDE or something as their desktop, and the desktop will come up. So the shell script is more along the lines of what happened, the login script is what's set automatically when the user logs in, and then that sets the environment for them. And you're talking, well, okay, environment. No, it's more than just access to the resources of the computer that they've logged into, and none of it is actually associated with a computer. It's associated with a network. So when you log into the network, you have access to all of the Sun systems, all of the Unix systems, as an example, that are in part of the network, and you're mapped which is an interesting concept. You're mapped to certain directory structures, and you share files with other users, and then you have some files that are your own, that you have your privileges to. So file access rights, directory mapping, all important issues for system administrators. Because it's not like a Windows system where you have a hard drive and you save everything to the hard drive. You don't necessarily have a hard drive that belongs to you. And then also, just because you're working, let's say you actually physically are sitting at one of these Unix boxes and you're working on it, doesn't mean that 200 other people are also sharing that same processor who are logged into that system, also working on it simultaneously. So it's a little different thinking. And you go back to Linux itself. It's not really Unix, actually. You just think about everything I just said about Unix a few minutes ago. You can't do that with Linux. I mean, you're mimicking Linux on a PC. You're mimicking Unix on a PC. You're calling it Linux. So the differences between Linux and Unix is the operating environment, essentially. I mean, it's running on a Windows kind of look and feel kind of system, but it's not really Unix. But for the purposes of this course, you're not going to go out and buy a $10,000 Unix box, which would be, ridiculous. So instead, you're going to use a boot up disk, and you're going to get Linux, which is going to give you the same kind of commands. And the interesting thing is this is actually not Linux. The Mac actually has a Unix version on it, BSD Unix, which is interesting. A lot of people call it Linux, but it isn't. It's Unix as the base operating system. So you can actually link MacBooks together and create. You can create a whole server out of it, actually, if you wanted to. No one's really going to do that, but the peer-to-peer is not too bad. Peer-to-peer services. Let's see if I can get back to that PowerPoint. Hello. There we go. Alright, so that I just demoed to you, the command line, and the concept of the shell, which is your command prompt window. Your shell doesn't have to be command line. Your shell can be a GUI, as I mentioned before as well. So Windows Explorer would be a shell for Microsoft Windows, as an example. Anything that loads another layer of abstraction on top of the operating system is considered a shell. So even though you're in Windows, you open up Explorer, it's a shell on top of a shell on top of a shell, which is kind of like how I typed in bash and C shell, and and I loaded shells on top of shells. It's really the same concept, essentially. So you might say, I'm not really a huge fan of Microsoft, but you might say that there's a lot of similarities in terms of the way the operating system is designed. It has file systems, it has services, it has all the components of an operating system. So. And if you really wanted to get into the concepts underlying, take an operating systems course. Then you see the services and the features of the operating systems and you can compare them across board. Alright, so let's look at common shells for a minute, and this is the boring part. Kind of have to go through some fundamental stuff. The shell, I was actually typing in C shell. I could type in SH and get a generic. SH was the original Unix shell. That's why the SH was short for shell. And it's still located in the bin shell directory. And I don't know if that directory is there, but when I go back, I'm going to check to see if I have bin. Actually, I'm pretty sure I do. And bash, which is the default for MacBooks these days. It's Unix written for GNU project, which is where BSD came from. And it's installed on most Linux systems. Most likely, you'll have a bash shell as well on your startup disk. If not, you don't like it, you can switch. And you can see how you do it, but just by typing in the name of the shell and you're opening up a new shell. It's kind of like when we typed in Win, we got Windows. Same kind of concept. Yeah, C shell is a C shell modeled after the C programming language. So the commands that are available for you in the shell, you can write C code natively. And you can save the C code and you can run it. You can say, printf, who wants to write C? So C programmers who are testing out code, who don't want to go back, compile, go back, compile, go back. You can go into a C shell, write your code, test out your statements, and you don't have to have a compiled program. The interpreter is built into the shell, which gives you some higher level functionality. The TC shell, Tish shell, is modern improvements, maybe has different parameters, different properties associated with it, which gives you a little bit more modern day file system support. Because your shell is going to determine like files, naming conventions, file size. And here we have improvements like file name completion that was added to it as an example. You know, where you type in the first couple of characters of the file and it gives you the whole thing. You know, it's like more automated, more up to date. And then really, nowadays, all these shells support the same thing. And people don't switch shells anymore because they all support the same thing. Hardly any of them support C anymore, though, which is interesting. Obviously, the more features you add to the shell, the more weight, the longer it takes to load sometimes. I don't know. We have an echo, and then we have $shell, which displays the shell that your account is using. And let me actually show you something here about the environment. Oops. I'm trying to use that thing where you... there we go. Go back to my... So, if I type in env as an example, what I'm getting, in fact, let me clear. I'll type in env. Env is a kind of an interesting looking command. It prints out your environment. And let's talk about Windows for a second, because most people are familiar with the autoexec.bat and the config.sys files of the old days of Windows. And what it did was it set environment variables, and we're still using it. Instead, now you go into system environment variables, and you set a path. You install Java, so now you added Java to your path, and you can, you know, basically change your environment variables. The same concept exists, but the information is populated from your login script. And if you type in env, you can actually see that here the shell is set to bash. So that's how come I ended up with a bash shell when I logged in from the terminal window. And my terminal color was set. My user was vhacker. It mounted some drives for me. It set a path here, and I got my path set up. It set shell level 1, which means I'm at the highest level. I can log in as root if I wanted to. I can log in as a different user. I can set up anything I want essentially in terms of the environment itself. And so we can actually call upon some of the environment variables that are set. And one of the environment variables that are set in terms of this lecture example is shell. So all of the environment variables that we have start out with a $sign, and they're normally in capital letters. And we just say echo space, in fact, oops, I'm going to say echo space $shell. And it should come back and tell me that my shell here is the bash shell. And because I have it up here, shell is equal to bash shell. Okay, fine and dandy, you're thinking, well, what's the difference between this and Windows? DOS is the same thing, right? Can you write a shell script in DOS that uses environment variables? No. Can you set environment variables from a shell script? No. Can you use environment variables like variables in a programming language? No. So, what you have now with Unix and Linux is a closer relationship between the programming environment and the environment of the operating system. And the environment of the operating system is available to you as a programmer. This is why programmers like Unix, they like shells, they like Perl, PHP, Python. You can actually get at information that's set for users, remap users, set environment variables, keep data about how long has this user been logged in, how many times has this user opened up files from this directory. You can use it for reporting purposes, for logging activities, for security. So you have, as a system administrator of a Unix environment, you have a lot more control over the users and the features that are associated with the environment variables, and you have direct access to the environment variables to be used in a program. In fact, you can write a regular old C program and use the environment variables inside. It's called the system level or system programming that works with system commands, environment variables, and all sorts of features of the operating system. So as a developer in Unix, you have a little bit more closer relationship with the environment. It's not something that you're just setting for the user's experience. You're using that information in your utilities or programs. Okay, so you can change your shell. You can actually type in CH, and I'm not going to do this because I think you guys could probably get the point at this point. Before I was typing in SH, CHS, and I was changing different shells, but I was not actually changing, I was adding a new shell on top of a shell and stacking shells up, which is not very energy or, I don't know, space efficient. If I type in CHSH, it'll change the shell from bash to something else. And so it exits one and enters into the other. So Saves a little bit more memory. If you think of the concept, if you keep entering in new shells, adding new shells on top of shells on top of shells, and you never log out, you never exit out of any of the shells, it takes up system memory. You can actually overload a Unix server by having too many simultaneous logins, too many simultaneous shells, which actually happens in the internet. So too many pings to a website, too many hits on a server. You're opening it up, opening it up, opening it up. Eventually you're going to run out of environment space to hold up all those users. That's how people take servers down, actually. So somebody knows something about Unix, can set it up to ping, login, ping, login, ping, login. Or not even that, just ping it over and over again and use up all the resources until the server goes down. Not such a good thing. Alright, so we actually looked at this already. Last time we looked at the man pages. I don't know if you're familiar, but on the internet, the man pages are actually integrated. In fact, you can go through a web browser, type in man. You can actually get to a web version of the man space, of the man variables. And I do believe it's also supported on this BSD Unix that's on this computer as well, but I'm not going to bother. And the type of manual itself, we already looked at this as well last time, I believe we looked at this. If not, I'm not going to go through it. So you have information. Man stands for manual. You have information on different commands, system calls, shells, everything you ever wanted to know information about. Okay, so now what I'm going to do is kind of go through a bunch of commands. And this is not really how you learn Unix, because you're not going to sit here, you might get some ideas about the equivalents. But you can't just sit, it's like learning DOS by memorizing commands. It's not going to work. That's what the focus of all the homework assignments are about. And next week I'll show you homework assignment number 1 and project number 1. And what I want to do with these is kind of go through examples out of them as I go through the lectures to kind of show you, because a lot of them have you write scripts, run commands, grep, do a find, all sorts of these different utilities. So I want to introduce the utilities to you, then next week I'm going to show you some more examples. I might demo some of them, who knows. Because we have some things like pipes and directions that we don't have in Unix, Windows, that we have in Unix that I'd like to demo for you as well. The convention, the command is in bold, the options are in italics. So this is lecture number 1 if you download it. Obviously you don't have to write it all down then. Okay, so in files, directories, structures, commands require input and options for inputs. So here's an example here where we have CP, which is a copy command. And in terms of the options, it's just kind of like, I think we could do this. Can't we do this? We should type in copy space, a name of a file, and then space, another name of a file in DOS. And we can actually kind of preface it with a path. So we can say copy // autoexec.bat to space // backup / autoexec.bat or something. Same kind of concept. However, in Unix and Linux, we have a little bit more control over the file structure. So we can copy recursively. We take copy everything from a subdirectory point forward or backwards. We could copy shortcuts. There's shortcut kind of copies. We can make symbolic links, and I'll talk about those in a few minutes. We can make all sorts of different types of directories, different types of files out of things. And in terms of the convention of the lecture, going through the command conventions, these are the options. So in here, when you see this here, it means there's options that you can add to copy. So you can go CP space, and then it's usually -F space, -L space, all these different, different command options that might exist. And here's some examples here: -R or CP recursive. There's shortcut and then there's long cut versions of it. This is where you get different breeds of Unix people. There's some people that like shortcuts, and there's some people that like the long ones. I personally like the shortcuts, but I never remember them. I mean, I can remember R, and their upper lowercase doesn't really matter. You can have it in either one. And this lecture is going to show you all the commands in uppercase, I believe. All the options in uppercase, but it doesn't really matter. It could be a lowercase r. So in here we have a short option, or we have long options. Long options have 2 spaces, 2 dashes. If you notice, this is what this is talking about. One has a short one. So these are what would be referred to as command switches, or command line arguments in a DOS world, if you're familiar with that. So, whose path is it anyway? Let's talk about the path a little bit, because we're going to talk about copying files for a second. Unix treats directory structures as hierarchies of individual paths. How it's actually stored on the hard drive is totally different. The storage allocation is set by a system administrator. Everybody has their own abstraction to the storage allocation. There's no coincidence. There's no correlating. You know, my home directory is on a drive. We don't know which drive it's on, really. I mean, usually it's stored by something, a disk partition that the system administrator has created. Your mapping isn't going to tell you that. So what we have here is the root. And an interesting part is in DOS environment, we have a very similar kind of relationship with the directory mapping and hard drive space, but it's partitioned out by drives. You have a C drive. Everybody's got a C drive, whether you want it or not. Sometimes you could take that C drive and partition that big hard drive into two, and what do you get? D. And then you get E, F, G. You don't even remember the alphabet. Every time you plug in a new device, a CD-ROM drive, a thumb drive, it increments by a drive letter automatically for you. So it's telling you that the operating system is really organizing everything by drive. In a Unix or Linux environment, we mount drives into directory structures. And the drive is the physical storage of the file system, not necessarily correlating with a particular drive, and it can span multiple drives. So our file system can go over 5 hard drives. We can have a C, a D, an E, an F, a G, an H, and I, which we don't have letters for anyway. We have mount points instead. And this particular thing could be spanning 3 disks, could be spanning 1 disk, could be spanning 12 disks. We don't know. So what do we get? We get economies of scale. We can add on hard drives. We can create more space when we need it. And we just map out the directory structure. So from a file storage capability perspective, this is very efficient. More so than running out of hard disk space on a hard drive and then adding in a new hard drive. Because you can't just easily move everything over, remap the entire file system onto a new drive. It doesn't work that way. In Unix or Linux, you grow it as you need it. You need more space, well then put in another drive. You mount another drive in there and then start to tree off in this direction. And the tree itself doesn't change. It just moves to the new drive. You know, things just move over and stuff. So it allows you to be more fault tolerant, pull out drives that are bad, replace drives. Your entire operating system doesn't crash. It just gets replaced by the new hard drive that you're putting in there. So you might think of this as sort of like an image that's being stored, and then the image is being mapped. The image itself is being stored on the drive. If you take an operating system, of course, you'll see the images in the first FAT partition. File allocation table, all of the information is at the beginning of the drive, is setting the structure for the entire drive usage. But and everything is stored by bit, byte by byte, you know, in some sort of an order, and it's read in an order. But in a Unix operating system, it's loaded into what's called an image, and the image itself exists, and it doesn't actually have to use the physical hard drive. You're not doing read and write directly to the drives at sometimes. In fact, it's not until you actually save something that it actually does get saved. So we have things, and you might have noticed, like fdisk and some of these other utilities that fix the file system because we have file system corruption. You just can't turn off a Unix box. You turn off a Unix box, all of the directory information changes, everything is in RAM. You turn it off, and you got file system corruption galore going on. You turn off a Windows box, no problem, you just turn it back on. You don't have as many lost clusters. You do have some, but you don't have as much damage done to it. So there's a couple pros and cons to the way that the file system is done, but however, it's a lot more efficient. So here we have the directory structure. Up here, this is the root. So we always have a root. We don't have a drive letter. There are no drive letters. We have roots, paths, and we have mount points. And we can create that level of abstraction on our own, and we can change it anytime we want. Doesn't really matter. This root here leads us to dev, home, user. From home, we have bhacker as an example. From user, we have bin. So we set up a map, and we map the directory structure. And then we organize, kind of like how you have my documents, my photos, you know, my pictures or whatever. It's the same kind of concept. In fact, that's where it came from. So going back to my comment earlier, XP kind of, 7, Windows in general, kind of mimics Linux in a lot of different ways. It's a slightly different implementation of it, but it kind of mimics it. Dev is usually restricted for root level or system administrator privileges, and I'll talk about privileges in a few minutes. Home is for everybody, and everybody has their own new home directory. So when I log in to bhacker in my terminal window here, I'm automatically taken to my home directory because of my login script that's set that way. And I don't have access to any, I probably do because I'm an admin level. But if I were a normal user, I wouldn't have access to anybody else's home directory, and I wouldn't have any access to anything else on the system. If I logged in, it looked like I had my own hard drive, actually. And I can organize my own hard drive any way I want. And I say that word with caution. You don't really have a home hard drive. You have space that's allocated to you. So you can take and allocate space per user instead of hard drive space, because you're not really writing to a hard drive. It's stored on a hard drive eventually, but you're not. Concept's not the same. It's not like your C drive, which is interesting. So we have working directories, we have relative directories, and absolute directories, because we actually are paying more attention to what's going on in terms of the path, in terms of the structure of this operating system. So the working directory, the directory your shell is normally currently associated with, which is normally your home directory for average users. PWD will let you view the path of the working directory, and ls will have you list out the content. I'm actually going to exit out for a second because I'm kind of interested here. PWD, so I'm in users bhacker, actually. If I go and change back to the root, I'm at the root level, and if I do a list out here, I do have a dev, and I do have a user directory, which is interesting. So if I went to dev, as an example, and then the change directory command, just like DOS, you'll find a lot of similarities between DOS and Unix. If I change the directory to dev and I do a list, I'm going to have bin in here. I should have a bin in here. Nope, I don't have a bin in here. You know what's off the root? Here it is. Here's the bin directory, and the bin directory gives me all the lists of commands. This would almost be like my programs. No, actually it's not my programs. It's my utilities. Pretty standard. Every distribution of Linux is going to have a bin directory. In bin, I'm going to have ls. If you see right here, I've got ls command here. I've got the echo command I used a little earlier. I've got kill for processes. I'll get into that. Make directory, move. CP is in here somewhere. Here's CP, cat. You know, all of the different things that I might want to do. Date. You know, all my system commands. If I am a root user, I'm going to have access to everything. If I'm a regular old user, I'm only going to have access to things that I'm supposed to have access to. So this directory listing is going to look smaller. In fact, bhacker logged into here is not a root. I can tell you right now, because I can't. There's some commands that are missing that are root level commands. So what we have then is the ability to have different user accounts with different privileges and different authorizations. So you might think, well, Windows has the same thing. I've got to figure out how to get that. I'm trying to get the screen back to my. You know what it is? I have too much grease on my. This is okay. There we go. Trying to do that, 4 fingers across. Doesn't work. It's a bummer. Huh. I think it's because I have too much dirt on my computer. Anyway, back to the lecture. So PWD gave me my path, ls gave me my view, and as I was mentioning before, in terms of the user directories and the user commands and the user control, we have a lot more. Things, and I'll show you the change mod command, in which we can set different access privileges to files, to directories, to paths. And not only can we map a certain way, and if you map it, the user has no access to it. If it's not in their map, if that access to that mount point is not accessible to them, they can't get to it. And then those things that are accessible to them, we can hide it from them. We can optionally show it to them, but not allow them to read it or to write to it or something. So, in terms of the system administration, there's a lot more capabilities than in a Windows system. So here we have finding your home, and this is actually an environment variable that's set. If we went back and looked at my env, I'd see home in there, and home would be set to user bhacker, I think is what it's set to. So each user has a home directory. It's usually stored as an environment variable, and I could go cd and then use this little squirrely thing, and it'll take me back to bhacker, which is a kind of a shortcut method. So a lot of the things you learn as a system administrator or as a Unix is all the shortcuts. In fact, every one of those commands that I've entered into the window I can't get back there. Ah, there we go. I have to swipe side to side. If I, that's clear. Yeah, you find out clear is useful. Clears this stuff out. My environment variable is set to, home is set to this here, because I just typed in EMV. And this is something, when you get your Linux distribution and you get it installed and you boot to that CD, type in EMV and see what's set. And then you can, unfortunately on a CD you can't change the environment and have it saved, but you can do it here. You can actually set environment. So you set ENV. Oops, nope, not going to be supported on this. I don't have root privileges actually, so I'm logged in as a user. But you can set the ENV, and you can add things to the environment, take things away from the environment, customize it, and it'll be good for that session. Once you turn the computer off, turn it back on, it's going to be gone if you're using that live CD. But here, if I go and use the squiggly line and go bheck home, oh, it's not going to be supported. Not going to be supported. So this is not going to be supported. Oh, no, you know what? Nope. So some things are going to be there. I probably just typed it in incorrectly. Some commands will work and some commands won't. You'll find this with different Linux distributions. There's slightly variance in terms of the command switches. Not too much of a variance. In fact, it's mostly consistent, which is kind of interesting. But I probably typed it in. No, I should have been bheck or not home. That's what I was going to. Actually, now I'm kind of curious if the tilde is supported. In fact, I typed it in correctly. Okay, it does work. All right, so I was typing in home environment variable. I should have used the $ in home if I wanted to actually reference bhecker that way. But so the tilde does support, which is good. There we go. Finally figuring. This is good practice for me to figure out how to get back and forth. So yeah, here we go. CD. This is what I should have typed in. I should have typed in that $ because I was referencing a environment variable, and use the $ and scripts and things to reference an environment variable. So the tilde will tell the shell to auto-complete the path statement for the CD, so it automatically completes it. So I don't have to type in the full path. So the tilde comes in handy when you don't want to type, because here's what happens: we're in a command line prompt, we're typing a bunch of commands. Are we going to sit there and type in /this, 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 or we just want to go to a certain point, go tilde, and in one directory, done. So what ends up happening as a system administrator is you learn the shortcuts. And the tilde is actually, I've got an exercise coming up in one of your assignments that uses the tilde, and this is what I'm calling a tilde. It's actually a Spanish character, Spanish special character, I believe, or French. Anyway, so the home refers to environment variable, which contains the path for home. We knew that, so we can actually use that. And here's some more file commands. And the CD, we've looked at the ls. The LSA is going to show us all the hidden files. And then you type in the man pages with ls, and you'll see all of the different switches. And V for move, CP, copy, RM for read. I'm not going to go through all of these commands. It would be a waste. But removing files, moving files, know that you could actually copy recursively through directory structures and take all this stuff here from home. Let's say I leave the company and I'm no longer there. I take bhecker home directory and copy it over to the new person, Sally, or whoever happens to be my replacement. And with one command, you can actually restructure the entire directory path. Give Sally everything I used to work on or something. And here's our recursive directories. So oftentimes manual will refer to recursive actions on directories. It actually is for files as well, and for folders and subfolders of folders. So it means to perform the action on a given directory recursively into all of the subdirectories. So we could change the names of everything recursively. We can move everything, copy everything recursively, delete everything recursively. Kind of scary to delete recursively. But if we have a bunch of nested stuff, we don't want to just delete, I don't know, can you do that in Windows? Just delete the C drive? Get everything gone? You can do that in Unix. And you just say, at the top of the mapping, at the top of the directory structure, just say delete recursively. Everything down is deleted for you automatically. So. And with that comes the caution of don't give everybody directory root access. And then you don't do that by giving everybody admin privileges. Which is kind of interesting because sometimes you log into Windows, you log into Unix systems, and everybody by default has admin privileges. I'm wondering if they actually knew the commands, they could just wipe out your entire system, like in a couple of sentences. Like, why are you doing that? Don't know. So we have this other thing. So relative and absolute paths. A little different, but kind of similar to the Windows environment. In terms of relative, we have commands that expect you to give them as a path to a file. So both of these are paths, examples, and we're looking at a file. So we want to copy a file, move a file. So we can look at it from a relative or an absolute path perspective. And in terms of your working directory, the // directory, the / is looking for the previous directory first. This is actually the same thing. We get this in Windows, and we can actually do this in DOS, but nobody ever does this. Actually, I shouldn't say that. Does anyone actually do this, use the dots? Nobody uses DOS these days. They all use Windows. That's the problem. In the other days, you used to go .. You could actually get to certain spots without having to retype everything. That's all this is doing. It's saving you work. Worked in DOS. The single dot says the directory or the working directory. So you're running a file, and this is the problem you'll get in Linux. You're in the directory, and you want to run the file, and it's not in your path. But you have to go .. / the name of the file. It means in my working directory, but I'm already here. Because it's not looking at that, it's looking at your path. So that's one of the things Unix people figure out instantly. When commands don't run, but they're seeing them. The command's right there in front of them, but they can't run it. Because they haven't specified that it's in their current directory. So in their directory is not in the path. If the directory was in the path, then it does work, which is sort of similar how the path works in DOS. Okay, so the absolute or the full paths are complete. Easy way to know if the full path is absolute, it doesn't contain the / character at the beginning, then we know it's absolute. So here I have a home user directory executable, a full path to a file executable. So this is the name of the file. And the interesting thing actually to take kind of a look at is the file types. And talking about directories, I can't talk about directories without talking about files. In Windows, we identify files by their extension. So everyone knows a .doc, DOC, or .docx now. In Windows, Microsoft Word file. And then we have exe files that are executable files. And we have, you can come up with a million of other examples of different file types. Not the case. If you notice that bin directory, we had no file extensions. We had ls, cp. So the directory structure, the paths, the file names aren't stored in a tree. They're not like Windows is. They're not stored in some sort of a lookup table where we say it's an exe file. If you change an exe file to a .txt file in Windows, the file won't run. In fact, Notepad will open up the binary code probably. In Unix, Linux, the information about the file itself is stored in its header. And so the file system reads the file, actually opens up and reads the file, looks at the header and goes, this is an executable file, and then treats it as an executable file. This is a text file, treats it as a text file. So we're not linked to, it's not the directory structure or the mapping or anything associated with the file system that's giving us our file types. It's the file itself, which makes it a little bit more extensible because we can add new file types. And we can have multiple different file types and file structures stored in the same directory path. Example, we have different types of file systems that we can load on. In fact, we can have the kernel loaded on for us. We could support Microsoft Windows files. We could support ext files, extended exts, HFS plus, HFS, just plain old HFS. We could store different types of file systems and mount them right into the same directory structure, which means we can share Mac formatted disks with Unix formatted disks, with Windows formatted disks. And because the file system and the way that the operating system is running is not dependent upon anything. It's self-examining. So we mount it in, we look at it, and this operating system, the kernel itself, has the support, hopefully, if we've loaded on the support, to kind of work with multiple different types of file systems all in one. So if you're thinking about, well, how does that work then? Well, Unix is flexible. We can load in different types of disks. We can reuse disks from different operating systems and not have to worry about it. You did that with a Mac system, a Windows computer is not going to read a Mac drive. Don't care how many times you try to mount it or load it, it's going to say it's not readable. Same problem. You just take an iPod that is formatted for a Mac system. And take it over to a Windows system. It's going to tell you, oh, it's formatted for Mac. We have to reformat it. Reformat it. Now it works on the Windows. Take it over to the Mac. Oh, no problem. It's a Windows disk. We can mount it. No problem. We know how to read it. So the support for a Unix environment, it's not operating system dependent on the file system. It supports all file systems. That's what I'm saying. All right, here are some poking around in the home. We can find out how much space we have, and these are the commands you type in. Quota. How much space do I have left? DF. Display space information of the entire system. These commands come in handy when you're trying to figure out, oh, I'm trying to copy something over. How much space is on this USB drive? And you can type it in and figure out how much space is on there. Helpful hints for space. Almost all commands that deal with file systems will display information in kilobytes and bytes. Nobody really finds this useful, actually. So you can say -H and you get it in megabytes. And you get, you have 1 meg left. You have 2 megs left. 3 megs. So you can change the format for how the information is actually being displayed to. So you go ls minus lh, for example, and it will give you the size that's available in free space, and I'll give it to you in megabytes or something. So you can change the format. Representing space, here's some examples here actually of, you don't need to know any of this stuff. So. Permissions. So let's see, we have, oops, it's 7 o'clock already. Wow, I got too far into this. I go for another 15 minutes or so. What do we got left here? Permissions. Maybe I should save permissions. You guys in a hurry? You guys catching buses? Okay, I'll go through permissions. So let's go through, because I already started permissions for a second. All right, so the system itself, and this is just an example of one system, can contain user, group, and others. Okay. So in a Windows operating system, we have guest, we have users. Do we have a password? Do we have an administrator? I think we have an administrator in there too. So it's often compared by profiles for different types of users. In Linux or Unix environments, we have privileges that are not by user, but by directory structure and by file. And we can put user access levels for individual users, for groups of users, and we can also make up users in terms of the other category, depending upon how we configure our system. So we can actually block different parts of the system and not different users who are accessing the system, if that makes sense. So the file permissions are arranged in 3 different groups, and they have 3 different characters associated with each one of the groups, and it's a read, write, and execute. And most people are familiar with this if they've ever done any web design, and they've uploaded files to a server, and they figure, oh, I have to change the permissions. I have to make it open to others, or open to groups or something. And you do this as an example. You have the owner that can read and write a file, others that will have read access, some people will have write access. And there's a command for it, and this is where most people who've taken a web class are familiar with this. They've FTP'd stuff over, and then the FTP client, if you're not familiar with that, it's File Transfer Protocol, will allow them to change permissions. Or you can type in change mod. You can also say change owner. So every file that's created on the system has 3 different levels of permissions that are associated with it for owner, group, other. And then it also has a registered owner. Somebody created that file, and that's the owner of the file. It could be a binary file that's compiled by somebody. It could be owned by root. It could be owned by user level. And depending upon who owns it, that owner can give access to somebody else. So going back to the distributed computing concept, this is how we can get a bunch of everyone sharing one drive. Because essentially everybody is sharing probably about 3 or 4 drives. In the average Unix system, you have about 3 or 4 boxes connected together. Each one of them is going to have a couple terabyte drive on it probably, maybe more. But all the users are sharing it. And any user who wants to can go access somebody else's files and things if they have access to it, which is how you can share files. And basically create a system in which you have security and that everything is not necessarily exposed. So. We have some other interesting commands all about me. You can type in who am I, it comes back and says who are you, returns the valid current user. Password, change your password, type in PASSWD. And I highly encourage you, once you get your boot disk ready, just go through and type in some of these commands. They should all work just fine, unless you make a typo. If you make a typo, it's not going to work. And the messages aren't going to be very user-friendly either. It's going to say, command not found. Okay. What group is supported? Well, if you have support for it, you could type in a group command. This one is actually not going to have a groups command on it. So, what everybody else is up to, you could say top, and it shows a detailed refresh description of the running processes on the system. And then uptime, which is going to tell you how long the system has been up. Actually, I think I'll stop after these commands. So if I typed in pwd, I've got, that's my path. If I type in who am I? Oh, I'm bhacker. Yeah. Uptime. This is how long my system has been up. Top. What's going on the top? Whoa, this is all the stuff that's going on my computer right now. I can figure out, well, what's going on? Oh, look at it, it's current. We got CPU utilization is going up. I don't know why it's changing like that, but alright, so let's Control C. We all know that one. Control C from DOS gets us out of everything. And then we have exit, which is going to close us down. Oh, I was in another shell. Oh, there we go, process complete. So next time around, we're going to start. For those of you who came in late, we're starting at 5 o'clock next week. This way I can talk for longer and not have to worry about you guys taking the bus too late at night. Because most people like to get out of here around 7-ish. And if I start at 6, I only get an hour. If I start at 5, I get 2 hours for you. So I can get longer next year, and we'll catch up next week. We'll go through a bunch of commands next week. But what I'm going to do is kind of stop for tonight. And for those people who are taking the bus and stuff, next week we are starting at 5 sharp. And we'll go till 7, so about the same time, but we'll have a longer lecture. And so your homework between now and next week, and if you're worried about not getting here till 6, that's fine, just come in late. And then we'll be here till 7, so you'll catch the second half. You can always look at the YouTube video and catch the first half, actually, if you missed it, or if you missed the entire class or something. And there's another class that runs simultaneous to this one, so I know some people will come here for the first hour and leave for the second. So next week I'm going to go through a lot more commands, and I'm going to start talking about the kernel. So next week's all about the kernel, and the kernel's the brains of the operation. I had an old computer that I used to build a kernel on. I don't know if I'm going to be able to do it because that computer's not booting properly. I can't really show you a live kernel build, but I might be able to find something that's demoing it. There's probably a video out there that's already doing it, but you'll see. It makes some sense to see how the kernel is configured and how the kernel is built, only because it gives you more perspective about modules, drivers, and stuff. It kind of helps you put the pieces together. So I'll work on that, see what I can put together. But that'll be next week's focus. Will be kernel and some more commands. Questions? Yes?
VI commands.
Yeah?
Do we use it on VI editor or on terminal?
It's VI is VI. VI. Watch this. VI. VI is an editor, and the editor is kind of like Notepad, except for its command line interface. And you just type in VI from a terminal prompt, and you have it on your computer. You have VI. I don't actually like VI. I like Nano or Pico. Nano. If I type in Nano, let's see if I can get out of here. Here we go. Exiting. Oh, let's see. You know, I don't like the command interface for VI. Quit. Nano gives you this. This is a file. You can type stuff in, right? And then go Control X. Oops. Then you can save it. Yes. It's all menu driven from this menu on the bottom. VI, you have to memorize escape sequences and commands, which is the exclamation point or the 2 colons. And you have to type in, like I had to do quit or something, or I don't know what it was before.
So what is it exactly?
It's a text editor.
So we use it just to write stuff into
text files. Yep. Source code files for programming languages, text files for documents that you're writing, notes to yourself, scripts. It's an editor. I would call it equivalent to Notepad, actually. VI is a Notepad for Windows, for Linux, Unix. Supported. It's one of the oldest editors, text editors, in the Unix and Linux. It's been around for years. A lot of teachers actually teach VI. I don't see any need for that because it's hardly ever used these days. And you can tell how long someone's been using Linux if they talk about VI and they load it up and they know how to use it. you go, oh my God, you've been using Linux forever. Because that was one of the original editors. Nano, Pico, some of the other ones that came after that. Obviously, you can tell this is a little bit more user-friendly. It's kind of like DOS Edit. In fact, I believe Edit's on here. Nope, it's not on here. There's another one called Edit, but you have to install it. Actually, the apt-get's not on here. I have to install a few utilities on here in order to get it, but I can download Edit. I'm going to show you this thing called apt-get that you can use on BSD. You can download Perl, you can download a bunch of utilities for free, but I have to install the apt-get utility. I don't have it on here, but yeah.
Why I asked is like, for example, we use this terminal thing to search files on a server.
Yep. Find or where is. Yeah.
Exactly. Edit a file or add a file. So if, for example, we are working in a company where we have something like ongoing updates on the server. So if we like on the terminal, if we do ls, so it will show only current what the files are currently.
Yeah, you can open up the file by using vi,
yes.
or you could use type.
So
yeah,
we use like VIL or something like that.
Say that one more time.
It's like to get the files which are currently being uploaded, like on the server. So if we type only ls, it will show the files which are.
You're piping. There. You're taking ls and you're sending it to a file, and you're opening it up in VI. I'm going to show you piping next week, actually. It's the second part of this lecture. You're taking doing an ls to get the directory listing. You're piping it, which means you're sending it to another application, VI, and you're opening it up in VI, because you can actually look at it, edit it, save it, make a log file out of it or something. Piping, it takes the output of one program, sends it as input into another program, and opens it up and uses it, and it's all in one command. It's one, like when you started saying VI
CP or something.
Yeah,
sure
you're piping. You have this command here in between. This one right here. It's hold on a second, let me get this bigger. It's this symbol right here. Is a pipe symbol. Filtering as well, and you're going to use that in one of your first homework assignments. Yep. You're going to be filtering it. Yeah. You're one of the first. It's either one of the projects or one of the homework assignments has you use this like over and over again. In fact, you'll be sick of it. And then we also have redirection. You might actually be doing, like for example, you can say ls and then use a redirection operator to send it somewhere. So I can send it to text file. Whoops. Oh, the direction. Test file, and then I can go nano, test file, and there's my ls. But that was two commands. I could have piped it into one, but I'll save it for next week. Because I have to like tell you more about. Huh?
How do you save the shell?
You can't save the shell. It's just like DOS. You exit, you're done. You can automate the shell by writing a shell. That's a very good question, actually. You can automate the shell by writing a shell script. And the shell script, you would open up the shell. In fact, I might even have a shell script in here. No, I took it out. I have to load my shell scripts in here. You could run, you open up the shell and then you just run the shell script. And it would actually go back through and automate, like, I'm going to run this command. I want to take all these files and I want to back them up for this user, and I want to take this user over here and I want to delete everything that he's got, and I want to clean up this, and I want to run an FSCK on the disk, and I want to do all these things. Instead of actually having to do them manually, you could just put all the commands into a script, open up the shell, run the script. So you saved ahead of time all of the work that you were going to do, and then every time you do it, you can automatically do it. And another interesting thing is you can actually have it run on a timer, schedule the job, and have it run in the background. But I'll show you how to do that. I can't show you all this stuff today. Background jobs, foreground jobs, shell scripts, automating commands and stuff. Topics for about 2 weeks from now. Actually, that's coming up after the kernel stuff. But that's how you do it. You can't actually save anything in the environment. I mean, everything you do is permanent. If you copied something or moved something, that's a permanent change. But all of the commands you're typing in, actually, usually there's an environment variable. Watch this. If, for example, I get lazy and I said, well, I just did an ls, and I just did a clear, and I just did. You can use the up and down arrows, and here I'm going up, and I'm scrolling through a list. So the shell has memory associated with it that's keeping track of all of the commands that I've typed in for this session. In fact, this is going back because I exited out of this session, I believe. I wonder if it goes back to the beginning. So it depends on how the shell is configured as to how much information is being stored. But there is a log file, and all this stuff can be actually archived for system administrator purposes, so you can see what your users are doing, actually. It's an audit way. But also it's for lazy people as well. Like, oh, there's the ls command. So if I found if I wrote this big old command out and I didn't want to type it again, just use the arrows. So, yeah?
I mean, previously, and there were a few scripts which was stored in name of .sh.
Yeah.
So that's .sh is...
People do that because they know it's a shell script.
Oh, okay.
You don't actually have to do that. People put .sh on it because they're Windows people.
Yeah.
And they want to know that it's a shell script. If you don't do that, it's not self-identifying. That's how in Unix you'll see people putting .txt at the end of a text file.
It can also be saved in the form of .sh, like in an extension file.
Well, as an example, just to illustrate the point, that file I created was called test file. Here it is right here. It does not have a TXT, but I can open it up as a TXT file. But I could have put the .txt. In fact, we did it for this. I did it for these things here. This is a .html file. But it tells me that test2 is HTML. I may not have remembered that. I don't even know. If I looked at this, I might think it's an executable, actually. And here's the interesting thing. We can take this file and change it into an executable file. Let's say the file was running some commands for us, and we didn't use a scripting language. We just opened up a text file and we put in there ls, a few other things. We can take and run a change mod command on it and put in 7755. Well, actually, I should have put the name of the file next to it. But we can change it and make it an executable file instead of a text file, instead of the default. And then we can just take and type the name of the file. Nothing's going to run. I don't have anything in there. But, permission denied. Okay. Because I have executable off. I have it turned off on there. It's just read write is what it is. But I'll show you some examples next time with a change mod where we could take a text file, turn it into an executable file, where we can, it's not a exe, but it's running commands for us automatically. Maybe it does ls 10 times or something. And these could just be regular old Linux commands, Unix commands. It doesn't have to be like a script. And we write a script in text. We change the file access, the properties to make it executable and to turn it on. Because here we have, permission denied, because it's not marked as an executable file. And I'll show you. There's a command. It's just too much to show you. I can show you the command to get the permissions. And after you get the permissions, you can see what it's at. I think it's like ls. Is it? No, that's, I don't know. I have to look it up actually because I can't remember. This is going to show you all of the hidden files with the dots. But there's many different commands that you can use to get the information, and then obviously once you know it, you can set it. So more stuff to learn. Okay, next class. Thank you.